Hello everyone, welcome to the session. So until the previous session, we have discussed about the mathematical intuition behind random forest. And I hope that that particular intuition is quite clear to everyone. If you haven't watched that session, please do watch that session before coming to this session. Because today, in this particular session, we will talk about the implementation for the same. So the today's session is mainly composed of the implementation of random forest. So we will see a live implementation, okay, of what we have discussed so far in the previous session called random forest. So we have discussed that this random forest is nothing new for us. It's just that multiple decision trees are working inside this particular model. And now we will see on top of one of the data set which I will use from here. So maybe let me first of all open a new notebook in the Google Colab, and then maybe we can start the session with taking one wine red quality data set, okay, that I have. So let me name the file of with a random forest implementation, okay, random forest implementation, and let me try to connect this file with my, you know, system. So let's try to connect this file. Once it will be get connected, I will try to upload the dataset that I have. So you can download this dataset by typing that wine quality red dataset. You will, but whatever be the first link you are getting, that from that particular link you can simply download this particular dataset which I am using here. Okay, once this dataset is downloaded, now the very first step is simply to first of all import all the required libraries that we have. So what are the required libraries? Import NumPy. I hope you all remember because previously also we used all these libraries. Then import pandas as PD. After that, import matplotlib.pyplot as PLT, right? After that, there is one library called cbone. So import cbone, maybe as an alias name we can give as SNS. Let me try to run this particular part, and now let me try to copy the path so that I will be able to read this file. So the data that I have is nothing but pd.read_csv. So this is the way to read the CSV file with the help of a pandas library. So now I will copy the path that I have, and then let's run this. So now here you can see that the data.head, if I will say simply data.head, so by default it will print to me top 5 records inside my data set. If suppose I want to see top 10 records, so I have to mention the number inside that particular parameter. So now here you will see the records from 0 to 9 is going to appear inside my screen. So here now if you will see, this dataset contains a fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol. So these are the features, and on the basis of these features, what I have to do is that, or what I want my model to do is that I want my model to predict that what is the quality of the data set. So if suppose I want to see how much numbers I have inside my quality data set. So here if we will see, there is 3, 4, 5, 6, 7 and 8. It indicates that in my data set, either the quality is 3 or 5 or 6 or 7 or 8. 3 means that the quality is not that much fine, and 8 means the quality is pretty good, right? These are the set of qualities that we have. So now what I want is that given the input feature that we have, whether it be fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, all these features, if I will give to the model, my model will be able to predict to me that what is the quality of the dataset that I am getting. So it will vary from 3 to 8. Okay, that is, I hope, is pretty much clear to everyone. Now, in order to see this part, let me try to create one correlation matrix. So that first of all, I will try to see that whether the features are correlated or not. If you remember in the previous session also, while implementing the decision tree, I hope so, what I did is that once I will be able to get an idea that if the feature is highly correlated, How we able to get? Once we will be able to create a correlation matrix. If suppose the value is maybe greater than 0.85 or minus 0.85, it means that those features are highly correlated. And when the features are highly correlated, what we can do is that we can delete those among those features, we can delete feature. We can take only one feature and remove all the features apart from that. So now let me try to write a code for a correlation matrix. But before that, let's try to see. So these are the, I would say, classes of target value, which is nothing but quality, right? This is the classes of target value, which is nothing but quality. And in the above part, if you see, here what we did is that we just import the required libraries. We just import the required libraries. Now, after that, in the next part is, this is reading of the file inside my dataset, given reading of the file of given data set, correct? And then this is somewhere you can say visualization of top 10 records. I would say top 10 records inside my data, correct? So once it is done, now what I can do is that this is done. Let me try to first of all check the description of this particular data that is given to me. So let's say description of the given data set, and how basically I can describe this particular data set which is given to me. I can say data dot describe. So this is the method to get the description, complete description of my data set. Here if you will see, now you will be able to get what is the count value. So with the help of this count value, I can say that there is no as such null value which is present. So this count value indicates to me that for every particular feature, I have 1599 number of records, as you can see. After that, I'm able to get the mean, STD, minimum value, Q1, 25 percentile, median, then 75 percentile, and then max. Correct? These are the records, these are the description of a dataset that we are getting, all in all. That's, I hope, is pretty much clear to everyone. Now, the very next step after the description is to get the, as of now, with the help of this count value also, we will be able to get an idea that there is no null value. But if we want to see that, to check the missing values inside my data set, so what we can do, I hope everyone remembers what is the by default function in Python which we use to check this part. Data dot is na, or you can say data dot is null, and then what I can say dot sum. So basically, with the help of this method, I will be able to get the value or get the idea that how many null values or how many non-null values are present. So here if you will see, there is no as such none record which is present inside my data set. That's great, because if there is any null value which is present inside my data set, at that point of time I have to do the sum of the imputation, whether it be with the help of a mean, median, mode, depending on the distribution of my data set, or maybe with the help of a K-NN model, we can do the direct data imputation as well. So these are the things which we have already discussed in our previous sessions also. So this is the way to check the missing values. Now I am pretty sure the missing values are also not there. Now let's talk about, I think, correlation matrix is the one which we have to see. So now let's see a correlation matrix. Let's see a correlation matrix among all features, I would say, inside the data set. Correct? Now let's try to imagine or visualize this particular part. So correlation matrix we can create with the help of a SNS library that we have. So what you can do is that in order to maximize the figure size, you can use plt.figure function, and then you can say fig size, and maybe I can say the figure size may be 30 cross 20. Okay. After getting this part, what I can say is correlation is nothing but data.core. So this is the function which is basically used to create the correlation matrix. Now what I will do is that I will say sns.heatmap, sns.heatmap, and this correlation I'll pass, and I'll say annotation variable is equals to true because I want the annotation also inside my correlation matrix. Now I can say plt.show in order to see the visualization inside my screen itself. Now here if you will see, this correlation matrix will be coming up. Now we can do one more thing. We can say plt.savefig, and here I can say it's a correlation matrix, right? Dot png. Let's try to see. So now if I will see it here, let me try to refresh this file. So you will see one more image. That image you can download also. Let me download the image and let me go towards the download part. Now here I am having the image. While doing a presentation, I think, just give me a second, it's not correct because we have to write it before this part. I think now it will show correctly. Let's see. So let me refresh the thing and let me download the same. And then let me extract this file. Yeah, now it is coming up, right? So here now you will see this is a correlation matrix. So these kind of figures you can use in order to demonstrate someone who is from non-programming background, right? So this kind of things. So this matrix is quite important. Here if you will see, every annotation is there, like fixed SDT and the quality. And what I can see is that all the numbers, if you will see, are lesser than a value called 0.80 or 0.85. It means there is no as such feature which I can see is very much highly correlated as far as I can see the numbers. So you can see the numbers, I hope, everyone. So this is the thing that we are able to clarify at that point of time. Okay, similar is the thing on this particular file also. I can easily able to see that. So there is no need to, I would say, remove any kind of feature. That's perfectly fine. Now the next part is to detect the outliers. Now next part is to detection of outliers. Now if you remember, in one of the sessions I told you that how basically you can detect the outliers with the help of a box plot. Today I will not show that part. I'll try to show you that with the help of a z-score, how basically we will be able to get the outliers. So detection of outliers may be using z-score. Please focus attention at this point of time. So today we will see another technique. So one technique, you know, which we have implemented in one of our implementation class itself. I think it's a decision tree, as far as I remember. Now in this part, we will see using z-score how basically we can detect the outliers. So this is a library in the stats. So basically you have to import from SkyPy. You can import the stats, okay, stats. Now after that, what you can do is that z is something which is np.apps, which is absolute value. What I want is stats.score, that is .z-score, I would say. And for what data? The name of the data is data itself. And now I want to print what is the value of z-score which I am getting. So import spelling is incorrect. So let me rectify that. So now basically if you will see, you will be able to get the, for all the number of records that you have, you will be able to get the z-score. Now, as far as I hope you guys know that whenever we're talking about outliers, so the concept says, according to the standard rule, thumb rule, that the value of z, if it is greater than 3, this is the threshold, right? 3 is the threshold. If the value is greater than 3, it means at that point of time, I can say that this is an outlier. So basically now what I have to detect is that on what particular records the value of z is greater than 3. If it is less than 3, that's completely fine. So what I can do is that I will say np.where the value of Z is somewhere greater than 3. And suppose I want to print this particular part. I want to print this particular part. And here, if you will see, you will get few records for which the value of Z is greater than 3. Now what I want is that I want to remove those records with whose Z score value is greater than 3, because I am treating those as a outlier. So now what I can do, let's try to understand this part. So what I will do is that I will say I am considering a new data, which is after the removal of outliers. I am taking the data inside which I am referring one condition. If the value of the Z is less than 3, take those records and axis is equals to 1. So this is the new data. Now if you will see new data dot, if I will say shape, let me try to see this. So I hope this is. So I am having 1451 records and 12 number of features. If I will say about original data, if you remember, my original data is somewhere which contains 1599 records. It means somehow now I will be able to remove the outliers, those outliers whose value of Z is greater than 3. That is the new data which I have. So it means today we did the removal of outliers with the help of a Z score. So those whose value of Z score is greater than 3, we just remove that. And now whatever we did, whether it be a splitting, whether it be applying a random forest on top of that, we do everything on this new data. Okay. I hope that this part is also pretty much clear to everyone. Now we can do one thing. We can split our data X into number of features in the final Y value. So what we can do is that so now what is happening is the next stage, which is a data splitting into features which I am considering as X and target column which I am considering as Y in my code. So here what I can do is that the value of X is somewhere equals to so for that I have to first of all import from sklearn. I hope everyone knows this part, model selection. We can import train test split, and after that what we can do is that X is somewhere which is equals to new data dot, I would drop the quality feature because that is my target value. So columns is equals to what I want to drop is quality, and the value of Y is somewhere is equals to, I would say, new data, and take the quality as the column in that part. So now let me try to see what is the problem. sklearn. So let me try to remove this. Now I think it's pretty much fine. So if I want to see what is the value present at X dot, oops, again head is this. So now if I want to see what is X dot head, I will be able to see that. Here if you will see, you have the features, you have all the input features. So here again I am saying X is somewhere you can say is the input feature which we will give to our model, and Y is somewhere we are saying is the outcome of that particular feature. So if I will say Y, so you will get some values which lies between 3 to 7 or 8, right? Feature splitting is done, sorry, data splitting is done. Now coming to the next part. Now what we have to do is that we have to apply the model. So let's try to apply now next phase is the data modeling, and that we are doing using random forest classifier. Correct? Now let me try to move ahead with this particular part. In order to do this particular thing, what we can do is that first of all we have to do the splitting now, correct? So before doing this part also, let me delete this. So what I want to do is I want to do the splitting. So here X train, okay, then X test is there, then I am having Y train, then I am having Y test, and what I will do here is that I will say train underscore test underscore split. What I will do is that X is there, Y is there, I can say test underscore size is maybe equals to 0.2 or 0.25, anything. You can also mention the random state if you want. Let's not mention that as of now. So this is the train test split which we did. Now this is the stage of, I would say, data modeling using random forest classifier. Using random forest classifier. Done? So now in order to do that, we have to first of all implement the random forest classifiers that we can implement with the help of from sklearn.ensemble, because that's an assembling technique which we studied. I talked about that is in the previous session itself. I will import the random forest classifier. Once it will be done, now I would say this is a classification, or I would say RF underscore classification model. So this is the random forest classification model where I can pass a random forest classifier, and here we have to define how many number of estimators we want to use. How many number of estimators we want to use. Suppose I am mentioning 100. It means that I want in my model 100 different decision trees play into picture in order to give the final outcome. Okay. Now what I want is that once it is done, so let me try to complete that. This is done. Now what I will do is that RF underscore classification model that we are getting, RF underscore classification model that we are getting, dot fit. I want to fit my model on the X train and Y train. Correct? This is done. Once it is done, what we can do is that we can actually do the predictions. So Y predict is something. So data modeling is done. Now we can say prediction of data using model, using, you can say, random forest model. Correct? Now once this is done, so how basically we can do the prediction? Let's take this model, and what function we can call is dot predict, and here what we can pass is the value of X test that we split. And here now if you will see, you will be able to get the quality value which lies from, I would say, 3 to 8. That is the range. So here if you will see, these are the predictions that my model is giving to me. Now if suppose I want to see the accuracy score of this my current random forest model, what I can do is that now this is something which you can say is data evaluation on metrics. So let's try to evaluate how is the performance of my model. So for that you have to import from sklearn, you have to import the something called metrics. Once you will be able to import, you can print what is the accuracy score that you are getting. What is the accuracy score? And that will be calculated by metrics dot accuracy score, and inside that you can mention X test and not X test, Y test, sorry, which is the actual, output, and Y pred, which is the predicted output that we are getting. Let's try to see. Accuracy from sklearn, we are importing the, so here it should be comma, not dot. Let's try to see now. So here if you will see, I am able to get a accuracy score of 0.70. So here if you will see, what I am getting as an output is that I am saying that overall my model score after applying whatsoever we did is 70.5% overall. This is the accuracy score as a final test data we are getting. Now, what we can do in order to optimize more optimization of our result, obviously we can use a hyper parameter tuning. We can uh, tune our hyperparameters because random forest model is taking so many parameters, and we just applied a normal random forest without thinking that what should be the optimal parameters that we can apply. So this can be done with the help of a grid search CV. So these things maybe I will discuss in the next particular session, where I'll talk about what is hyperparameter tuning and how basically we will be able to optimize our code on top of that, right? So this is one of the way with the help of which you will be able to optimize your score. Your score might be, you will be able to get a good score. Suppose I want to see the tree. So in that particular case, whatever model I have applied, what I can do is that from sklearn, I can simply import the tree. Okay, in order to just visualization purpose, just like the way I showed to you in decision tree, let me try to show you. So what you can write is tree dot plot underscore tree, and whatsoever be your classification model, that is nothing but rf underscore classification model. So let me copy the name. So this is my model name. What you have to do, you have to call the estimator. So if you remember, I am using 100 estimators. So suppose I want to see just the 0th estimator, how it will look like. Filled is the value which is equals to true because I want inside the node data to be there. So you can see the plot also. So here you can see for only single decision tree, because there are 100 different decision trees coming into picture. If you will say 0, 1, 2, 3 up to 99, you will be able to get the data. If suppose you want to see in one go every particular decision tree in a one go, so in that particular case, obviously you have to say plt dot figure, and here is some fixed size which you can demonstrate. Obviously fixed size, suppose I am saying it's 20 cross 20 or 30 cross 30, anything you may want. And then first of all you have to make a for loop for I in range. What is the length of the classification model, dot estimator, right? What I am saying is that I am saying print this. So what's the command which I used in the above case is the same command I'll try to use here. But now instead of saying 0, I will say it as I. So in that particular case, it will run from 0 to 99. So try to run it this at your home. You will be able to get a big decision tree. Decision tree which is composed of 100 different decision trees, and that is nothing but random forest. Here, if you will see again, the size is very small, so I can increase the size with the help of the same command here also. So what I can do is I can simply say such type of things in order to get a bigger one, correct? So basically this is how you can work at your home in order to visualize the big tree also. So this is a similar thing that I illustrated in the decision tree part itself. But I think overall overview related to how basically this random forest algorithm is usually implemented is pretty much clear to everyone. Now you can see it's a big tree which is quite visible as comparable to the above previous one where the size is too small. So whenever we want to increase the size of the plot, you just have to do one thing. You just have to manually write this particular thing, that the fixed size which you want. And this is the way to implement any kind of random forest algorithm. Again, I am saying that this is one of the very powerful algorithm which you can use in order to get the better accuracy, in order to get the better predictions. And yeah, in next particular session, maybe I'll try to show you what is hyperparameter tuning and how basically we can tune our model according to the methods. For example, I talk about grid search CV. So yeah, with this, I would like to end this particular session. Hope you guys really enjoyed that how basically this random forest implementation is to be done. I try to do it live so that you guys will be able to understand each and every part a little bit. And whenever we are writing the code, we usually face some sort of issue that might be you guys also facing, and so that you will be also able to understand that at what point of time, whenever issue is coming, how basically we can resolve that. So with this, I would like to end this particular session. Happy learning to all. Bye bye. See you soon in the next upcoming session, where now maybe we will talk about some other interesting topics.